Hey there, this is Mitchell and welcome to another video in the RSP education series. Today, we're going to talk about modems versus routers. We're going to decode this industrial tech so that anyone can understand it, and so also that the most hardened PLC programmer or network admin can smile in approval. As always, these videos are for educational purposes only. Always consult a qualified professional for guidance on your specific application. RSP Supply is not liable for misuse of the information provided. With that said, let's get right into it. So today we're going to tackle a key question in industrial networking, very confusing topic that not a lot of people have a lot of clarity on. Modems versus routers. What are they? What do they do? Why are they critical for your facility's network reliability? So stick around, and by the end, you'll be the go-to person for all things network architecture, at least until the next Ethernet storm. Fingers crossed. Let's start with the modem. In an industrial environment, think of it as the translator between your facility's internal network and your internet service provider, or sometimes it'll be a dedicated remote system. The modem's job is to handle modulation and demodulation, which is going to convert digital signals from your controllers, SCADA systems, or routers into signals your ISP can process, and vice versa, hence the name modem. So let's break down modulating and demodulating in simpler terms. Think of modulating as sending data. This is what's happening when your automation system, like a PLC or a sensor out in the field, wants to send data back to a remote control center or the cloud. The challenge is data's digital. So the PLC or the SCADA, other machines, they only produce data as in digital signals, like ones and zeros, like on a computer. The problem is the transmission medium can't carry digital signals though. For example, a phone line like DSL or radio waves can only carry analog signals, continuous waves. So the solution is modulation. The modem converts or modulates the digital signal from the PLC or sensor into an analog signal so it can travel over the chosen medium. Now let's discuss demodulating. Demodulating, think of it as receiving data. This is when the control center or SCADA system receives the modulated analog data and converts it back into digital signals that the monitoring and control systems understand. So let's actually break this down into a couple of everyday solutions that are more familiar to our daily use cases. Remote monitoring would be one. So think of a temperature sensor at a water treatment plant sending data to a central SCADA system located miles away. The modem at the plant is going to modulate the digital sensor data into an analog signal so it can travel over a cellular network. Then the modem at the control center is going to demodulate the analog signal back into digital data for the SCADA system to use. Another use case is wireless communication. Imagine a mining site that's using wireless modems to send data from drilling machines to a central control station. The modem is going to modulate the data into radio waves for transmission from field to control center, and once it arrives, it will demodulate the radio wave back into digital data at the receiving end. It's the gatekeeper of your internet connection, kind of like the IT equivalent of a flow control valve. And just like a valve, if it's clogged or misconfigured, things get messy. Trust me, nothing's going to get a network admin sweating faster than a modem on strike. Industrial modems typically connect directly to your ISP through coaxial, DSL, or in most modern setups, hopefully, fiber, which, by the way, is the gold standard. It's like giving your network a Ferrari to drive instead of a rusty old pickup truck. But the kicker is, by itself, a modem can only manage one direct connection. That's right, just one. Enter the router. Let's talk about the router, the maestro of your industrial network. While the modem handles the external connection, the router takes that internet signal and distributes it to your entire facility or field. Imagine your router as the plant's control system scheduler, making sure every device gets its fair share of bandwidth, whether it's your HMI calling for data, or your historian system on the SCADA logging process trends. Let's not forget, it does all of this without complaining, until someone spills coffee on it, of course. So let's discuss the key functions of a router in industrial automation. Data routing is one of the big use cases. Routers are going to analyze incoming data packets and direct them to the appropriate destination, whether that's within a local network, like a factory floor, or across wider networks, such as in remote monitoring systems. For example, a router is going to make sure that the temperature readings from a sensor are sent to the correct PLC for processing. You can think of it kind of as like an air traffic controller for your factory. Network segmentation is another task that routers perform. Routers are going to create and manage virtual local area networks, or VLANs, to segment traffic for different processes. This enhances network efficiency and security. For example, it's important to separate communication for safety systems from general production data to prevent interference. You can imagine having separate lanes on a highway, one for big 18-wheelers and another for the guy who always insists on driving 10 miles per hour under the speed limit. If you've ever driven in Utah, you know exactly what I'm talking about. Remote connectivity. This is another function routers perform. Routers are going to enable remote access to automation systems for maintenance, troubleshooting, monitoring. This is done through those virtual private networks we talked about, ensuring secure communication between remote users and the plant. A very common use case for this, more and more frequently going on, is to allow an engineer to fix a machine from their couch or from the office instead of needing to be out in the field. Protocol conversion is another task. Routers are going to bridge devices that use different communication protocols, such as older Modbus, TCP, or Ethernet IP, or OPC UA. For example, a router is going to translate that data between a legacy system using Modbus and a more up-to-date modern SCADA system that's using Ethernet IP. Cybersecurity is another function for routers. Industrial routers often include features like firewalls, intrusion detection, prevention system, which IDS, IPS are abbreviations, and secure tunneling protocols to protect critical infrastructure from cyber threats. For example, they'll block unauthorized access attempts while at the same time allowing authenticated engineers to remotely access equipment. Think of it as a bouncer for your network. Password, please, or you're not getting in, pal. Quality of service. Routers prioritize critical data, like safety alerts, over less critical data systems like system logs, to ensure reliable operation in real-time applications. Very crucial. For example, a router is going to prioritize emergency stop signals over general monitoring data in a manufacturing line. Together, modems and routers are like the powerhouse duo of industrial network management. Kind of like your most reliable operator and maintenance tech, always in sync. And just like that duo, if one of them isn't working, the whole shift's about to be a nightmare. Some of you might be asking now, why not just use a combined modem router? And you'd be right. Some setups do exactly that. These units are handy in smaller facilities or non-critical applications, but they often lack the advanced capabilities that industrial environments that we work in are going to demand. Think of it kind of like a multi-tool. It's great in a pinch, but you wouldn't want to build an entire production line with one. So separate modems and routers are definitely the way to go, giving you better flexibility, scalability, and the ability to add redundancy, because downtime in automation isn't just annoying, it's very expensive. And we all know the only thing scarier than downtime is explaining it to upper management. So there you have it. For a full line of modems, routers, and thousands of industrial products, please go to our website. And if you like this content and want more educational videos, please like and subscribe. For more information, more videos, rspsupply.com is your hub and the internet's top source for industrial hardware.